10 months ago, I uploaded a video on how to fake caustics in Blender. Now that video was primarily targeted towards the render engine Cycles, but Blender has another render engine. It's called Eevee. In comparison to Cycles, Eevee does not produce that realistic results. First of all, thank you for commenting on my video. Secondly, the answer to that question is that every method except the one in which we use light nodes is applicable to Eevee. The reason being, we are simulating realistic caustics in Blender and not real caustics. Realistic caustics look like caustics and real caustics are actual caustics. Unlike Cycles, Eevee does not produce that realistic results, and same goes for the caustics. This happens because Eevee in itself as a render engine cannot simulate real caustics, you always have to fake them. So since we are faking it, it's the same on Cycle and Eevee. Now when I was researching to find an answer to that question, I came across an interesting point. Now in my previous video, in the last method, we do not fake caustics using light. We simply embed the texture of the caustics on the caustics receiver. In that video, I used a water layer and below it was the caustic receiver. It was completely submerged in that water. Now because that caustic receiver was completely submerged under the water, all points of that receiver would receive the caustics. In our case, the refractive object is larger in size than the caustic receiver. What if the caustic receiver is larger than the refractive object? Now you might think, how is that a problem? Smaller or larger? How is that relevant? Well, the thing is, caustics only appear where the shadows are cast. We need to isolate the area of the caustic receiver on which the refractive material casts a shadow on. Also, if your lights are not perpendicular to the caustic receiver and are kind of angled, the caustics are not gonna look realistic. So that's a limitation we're gonna address in this video. I'm Rex and let's get into it. Alright, so here we are in Blender. First let's select everything and hit delete. Now I'm gonna press Shift A and I'm gonna bring a monkey. I'm gonna bring in a monkey. Now I'm just gonna move this monkey upwards. Now this monkey would be our refractive object. So let's give it a texture. I'm just gonna split my screen, shader editor. By the way, this is all in Eevee, so it works on both. I'm gonna set the roughness to 0, base color complete white. I'm gonna dial up the transmission all the way to 1. Secondly, I'm gonna go to render tab and I'm gonna enable screen space reflections. Alright, perfect. Now I'm just gonna add an environment texture, Ctrl T with no triangular enabled. Now if you go into rendered view, perfect. This is what our world texture looks like. And this is what our refractive material looks like. Now I'm gonna add a sunlight. Now let's bring the sunlight above the refractive material. Now let's get a mesh, a plane, and let's scale it up. Apply all transforms. Now we can see our object already has a shadow, but that's not relevant to us. We are only gonna use this shadow to determine the area that we're gonna mask out. But come on, how's that possible? Well, it is using geometry nodes. I'm just gonna select this plane. I'm gonna go to geometry node editor. I'm gonna click new and this is what we have. Now get an empty. Plane axis is good enough. Now select your empty, then select your light source and hit Ctrl P. Now select object. Now our empty axis is parented to the light. Wherever we move our light on, the empty is gonna move with it. Now the reason why I put this empty and want it to remain below the light source is because we're gonna do some math. Remember high school when you were intelligent before you chose 3D art as a career? Now whatever we do with our light source, our empty would always remain below it. I'm gonna go to shader editor. Let's give it a new texture. The base color would be black. Roughness 0. Specular, for the sake of demonstration, I'm gonna set it to 0. But you can change this if you want. Now what we're gonna do is that we're gonna import our light and our refractive object here. We will also import the empty as a separate object. Now this is a spoiler, but for the sake of demonstration, I'm gonna search for a stored named attribute. We're basically gonna use an attribute called CD as our color to mask out the shadow of the object. If shadow exists, the color is white. If shadow doesn't, it's black. Get a Raycast node and connect our refractive object to the target geometry. Now let's get a vector math. Connect the location of our empty into the bottom input. Connect the location of our light source into the top input and set it to subtract. Now plug the result into the ray direction. Now connect the is hit to the value. Now get a set material, add it here, and we're gonna choose the material that we just created. Set the refractive object as relative. Now in our shader editor, we can connect this color to the emission path and we can set the strength to 1. Perfect. Now as you can see, nothing has happened because this method takes a bit of geometry to work. So I'm just gonna subdivide it, and there you go. And as you can see, we've detected our shadows as a masked texture. But this is fake, right? Well, I'm gonna prove it to you. This is our light source. Now if I rotate it towards the y-axis, it follows the direction of the light. If I rotate it towards the x-axis, it follows the direction of the light. And you want to see something cool, we can do some really cool effects with it. If I write dollar, oh no, that's Houdini. I need to write hashtag frame, and if I play this now, let's slow it down a little. Frame divided by 100. You can see the shadow is followed by the light. It's procedural, requires no baking, no Python, and no simulations, and works in cycles and EV. The only downside of this method is that it requires quite some geometry. Now if I unsubdivide it a couple of times, maybe more than a couple of times, you can see it messes up. It does not work with low poly geometry. That is because we're using an attribute, and the more of points there are, the more detailed the attribute's gonna be. So I'm just gonna divide it again. Now back to the original question. How is this relevant in Caustics? Well, the thing is, now that we have a masked area, we can go in our shader editor. I'm gonna use a very basic Voronoi texture as our caustic texture. Color RAM. Now get a math node, add it, set it to multiply. As you can see, we have caustics only on the object's shadow. That's it for this video, and I'll see you next time. Bye bye.